So the first thing is the presentation is to come up. So thank you very much for being here. My name is Jesus Escolar. I'm the CEO of Escolar. We are a company built after a few years of investment in the security ecosystem. And today we're going to talk about containers. I'm going to walk you through the container ecosystem, and also I'm going to tell you what is available today as solutions that can provide security, and also splitting them into different types of security elements that we can process when we're working with containers. So, first thing to understand is that we passed from the physical hardware or the bare metal, where we started constructing our applications and servers, and we built on top of that virtualization with different solutions, as you can see the screen, and also we moved into cloud computing, and later on we had a need to put all of these solutions that we were working with into a more compartmentalized and a more contained environment, and that's how we came with the solution of containers. And we build containers for two things. We build containers for applications, and also we build container to put OSs, operating systems, and deploy them fast, quick, and without the complexity of the virtualization, and not so depending on vendors or manufacturers of specific types of hardware or specific types of virtualization solutions. And the last evolution that we're going through now is function as a service, which means instead of having to run those applications, the applications already exist in your ecosystem, and what you build is code in between those applications to extract from one specific service or provider an output and put it as an input with your transformation into another vendor or another solution. And that's what we're working toward, into containers and functions as a service. So when we started talking about containers, it's something so new and so interesting, and people is so excited today, and there is a buzzword. We all love buzzwords, okay? But then it comes to the reality. Containers started in the 70s. It didn't start yesterday. It didn't start 5 years ago. So we started building isolation in the old mainframes with the old applications that we had at that time. And that was the beginning of container, isolating. That's the word that you need to keep today. Isolate and compartmentalize. We evolved over the years, so you see there is a lot of years in between 70 and 2000 before somebody came with the idea of doing the same thing at a higher scale. Later on, we moved into creating a more better defined logic behind compartmentalized applications. In the beginning, it was just compartmentalized shared resources, and later on, with some microsystems, we were able to create zones, which was basically a way to isolate parts of the OS to actually provide RAM, disk access, and CPU access to specific applications. That was really the first time we had something that we could call a container. Then, another time, another period of dark ages where nobody really did too many things around it, and we moved into OpenVZ. OpenVZ was the first product that we could actually use to create many different instances of full pseudo OSs, at that time only Linux, and Linux up to now, where we could run different applications. So, for example, ourselves, myself as an individual, I used it to create one of them in my computer where I could VPN through the internet and do a home-to-home private connection. Or, for example, to run an encapsulation of my traffic over DNS, which is something that you shouldn't be doing, but I did it just to test it and to see how I could pass traffic from one point to the other using DNS. And then, obviously, the big guys came into play. Google said, okay, well, I like the idea, as they had thousands of engineers. They said, okay, we're going to build something more interesting. We're going to make something commercial, free, open, and then commercial. And they started with the concept of process containers, where they actually isolated the whole logic. And now we were getting close to the reality of the container, something that you could actually play at home and play in the companies. Google passed that to other engineers that they took the code and they built the Linux containers. The first time we had a real solution that we could use, LXC. LXC is what you know today as LXD, if you ever work with containers, and it's actually what is the basis for most of the container ecosystem. Obviously, behind that, there was the need to create more tools that could actually provide capacity to be into the commercial space and also into the organizations. A few companies came after. I'm not going to talk about the second one. Cloud Foundry was good because they brought something very important, an API, so people could actually develop things remotely and access, transform, and change without having to know anything about the subsystems. So they didn't have to go in the low level. They could do it just with an API. And in 2013, the Holy Grail came into place, which is Docker. And I'm pretty sure that everybody here would never use containers, but these days in the IT or in any other type of area from computer systems knows about the word Docker. And Docker was our backend to actually build the reality that we have now. Docker brought something that nobody else did. They brought an ecosystem similar in logic as a metaphor to what Apple has done with the applications. They brought a place to download and to actually recover images. So if I need, for example, a web server, I can choose from any of the images of the available web servers and get it installed in my Docker implementation. I just have to type a command and I get it. I don't even need to think about it. It's just in the list, and the list is nearly eternal. It never finishes. It keeps on growing every day. So that ability, plus obviously all the ability to do the management and the orchestration, was what brought today Docker to the level where they are. And everybody now is building products on top of Docker. But we need to think about security. So what is the logic behind containers? When you look about containers, you think, I don't understand them very well. It's pretty simple. In the image that you have here, you have a definition on what is the virtualization, transforming physical hardware into a virtual environment in a place where I can run many servers and services on top of the same hardware. But the problem is that every time I do that, I need to construct again an operating system. I need to create one and put my applications on top. It's very nice, it's very easy. It's today nearly a monkey job. You can actually do it sequentially so fast that nobody even cares today. But the problem comes that it's very big, it's very time consuming, it's very difficult to revert back, and also it can't scale as fast as required for certain type of applications. The container side is different. In the container side, we have the same infrastructure, but we have something that we call a container engine, which is one of the actual brands today, or vendors, that actually provides one of these engines, or even the open source ones. And then on top of that, the only thing you do is you have shared binaries, shared executables, shared programs, and shared libraries that are used by the same applications that you put on top. And so instead of having to put operating systems, you put applications. And you can replicate that in the order of millions in the matter of minutes. So if I have, for example, a web server, I can spin 10,000 web servers in probably 1 minute if I have the power, I have enough power server resources. So that's a big difference. But as you see, a new problem arises. We are sharing resources in the backend, while in the virtualization, we are not. So, talking about security now, that's why we are here. The landscape of the security is based on what we see here, the technical dynamics and the customer pain. Everything that is about security ends up giving a lot of pain to our customers. At the moment, we see that the infrastructure evolves. It keeps on changing from physical, virtual, containers, cloud. Then we get the applications that keep on changing all the time because we got continuous integration and continuous development. So we cannot do like in the past. We wait for release 15, then 15.1, then 16, then 16.2. We cannot do that. We need to deploy applications very fast. And also we have the threats. If you are familiar with all the problematic today about the new generation of threats, is they keep evolving all the time. They keep evolving even by the time that we are talking. Since I arrived to the building, to the time I'm going to exit this building, probably at least 2 new variants of malware will have been created. Not 2,000, sorry. So that's actually the reality. The threats keep on evolving, and that ends up in people having to do a lot of audits and threat assessments, people having to look into how they're gonna not impact the performance of their infrastructure, and also how they're gonna try to simplify their IT to do not have to scale way more than the infrastructure requires just because of the complexity. And that ends, obviously, in customer pain. This is the picture that you need to keep in your brain. This is the model, the most important model that has been ever developed in the last 5 years for security in all the hybrid ecosystem on clouds, containers, functions as a service, anything that is built from an organization or that is consumed by an organization and deployed to your B2C or B2B. At the moment, the shared responsibility model is what you need to focus on. It's the most important. It separates the foundation services that you see there and your infrastructure from what is used or consumed by your users or by your actual employees. And the responsibility, when you are, for example, using Google Cloud or Amazon Cloud or Microsoft Cloud, or you build a cloud with your brand and your name and you give it to your customers, the part that is below, okay, in dark, that's your responsibility. But whoever uses the cloud at the moment and puts applications and puts any services, any OSs, anything, and gives it to the customers, everything on pink is your responsibility. So if you're a developer and you develop applications, you need to take care about all of the rest. You can find this in the Google webpage, in the Amazon webpage, or you can find it in the Microsoft Azure webpage. It's a model that is totally approved and accepted. So all of that is your responsibility. You will think like, if I am using Google Cloud or Amazon Cloud or any other cloud, or let's call it Paris Cloud, I am not responsible for it. They will take care of it. It's not the case. It's your responsibility. And therefore, all of that comes into what do I need to secure when I come into containers? When I create these containerized applications, how do I secure them? So my problem is, do I secure the host where I run my container engine? Do I secure the applications I develop? Do I secure the images that I package and I prepare to be deployed across all my organization or my customers? Do I look into the permissions? Do I look into the users I create? Or do I look into the traffic from the consumers? Do I look into all of them or none of them? Well, the problem is that you probably have to look across all of them at the same time. But there is not a single solution. And that's where we come with the paradigm that we have for containers, which is totally different from the paradigm that you have for virtual resources or virtualization. So we know that the containers are running on top of an OS all the time, an operating system. We like it or not. Then they are also running either an OS themselves, an operating system, or applications. Also, they have libraries that they use to actually execute the code. And also these libraries are shared across others, which is another big problem because we cannot have isolated libraries. It would become, again, a virtualized environment. And still, we have to think about how do we deal with the multi-tenancy and the multi-users. For example, you, and you are using my containers, and you, and you are using the same. And it happens that we're sharing the libraries. So who is responsible for one of the libraries being hacked or being actually forged, okay? We need to actually think about the fact that we share the same. It's like I like to think this about a toilet. You know, when you go to a toilet, you don't have your isolated space. You're always sharing a space with the rest of the people there. So you need to think that the same toilet that you're using, somebody else is using it too. So you may get to the toilet and get totally infected. And you need to think because somebody came and just did something dodgy in the toilet. So you need to think about dirty things to actually have the security always present. So we got accountability, vulnerability, patching the systems, the applications, firewalling, who manages the traffic? Do I go back to my provider and I complain about not having a proper firewall? Do I get breached and I go and I say, your firewall is bad? Or it was me that did a bad coding and I didn't think about putting any security solutions on it. And what about role-based access control? Who manages the accounts? Who puts them in the right place? Who actually decides who can get in and who can get out? It's a lot of problems that you need to think about. And then it comes to, how do I secure them? So a very interesting thing is, let's do resource control, you know? Let's go and use C groups in Linux and do a lot of resource control. Fine. Or let's do a discretionary access. I define what I want people to access to. Or a mandatory one, so I start using AppArmor or SE Linux, okay? Or maybe I try to use secure computing with fine-grained access. But all of that is so complex that at the end of the day, I may lose track of what I've done. Do they work? Do I start employing DevSecOps people or the SecDevOps people into it? Or do I try to find an understanding on the ecosystem on what is going to be the best? So, security solutions that we define in different groups. We got for vulnerabilities. I'm talking open source all the time. They got a commercial version. New Vector, it uses the CIS, Center for Internet Security, takes your images, looks into the image, and defines if the image is validated or not based on the CIS database for free. AquaSec does exactly the same thing. It lists if your images, okay, is actually validated or not, and if you have the right permissions, okay, in your Kubernetes cluster. Corie OS, it is even another approach, which is about vulnerabilities, which takes the images, the packages that you have created in standby, and it actually analyzes them as a static analysis to see if they are vulnerated or not. So it compares with different types of CVEs and defines if they actually have any vulnerability that needs to be considered. TwistLock is another, all of them are commercial, but they have a free open source. TwistLock is very interesting because they do vulnerability management for the actual images and containers, access control, and also when the container is running, it's in operation, it looks about the runtime, the in real-time execution to see if something is actually going wrong. I like them very much. Actually, they got a full product that you can use as a community edition. So if you don't need to get into corporate levels and pay for it, you can actually test it even in production as a community edition. Later on, you can get into the proper, commercial stage. Aqua goes to analysis, no more vulnerabilities. So Aqua is actually looking into the pre-production analysis, okay, and the vulnerability, and then you submit an image and see if they have vulnerabilities. So you create your content when you're developing and you put it into Aqua, and then it looks into the files and see if the files have been tampered with. So all your code and all your actual application can be analyzed, and then later on decide if it's good or bad, based on your policies that you create. Sysdig does also something which is related with behavior. As you see, all of them, they complement themselves. Sysdig does behavioral analysis to detect anomalies based on a baseline. You create a baseline and you see if there are any anomalies into your containers. And also that's very good because it works also for poor containers or microservices. And Notary is the last thing I'm going to talk about, is just about making sure that there is no forgery in the images. When you create the images, you need to put them in a repository. And in that repository, you need to actually have a proper database where you're going to deploy those images to. And Notary is implemented into the Docker as the update framework in GitHub. Well, now it's Microsoft, but I'm not going to talk about that. And the goal of Notary is to say, my images are good, they're not tampered, you can download them. It's the same thing as any update that you get today that is validated and non-tampered with. What's next? What's the future then? We don't know it. It's very unclear. We're lacking a lot of understanding about how containers are going to evolve, and we lack also the understanding of how the solutions are going to be implemented. So the host can be infected, the images can be vulnerated, the images can be tampered with, the files can be tampered with. It was demonstrated in the Black Hat conference last year how somebody took an image and totally fully fill it with malware and demonstrate how people download it and execute the image from a repository and it was infected. So there is a need for a next generation solution in an open source for all of us based on the capabilities that are required today from any other type of security solution. Anti-malware, IPS, web reputation, behavior monitoring, machine learning, artificial intelligence, and also sandboxing to actually determine that the files and the content are good. But there is nothing new. There is nothing new in the market. Everything is pieces all together. And today the ecosystem is so sparse. There are I would say like tens and tens of solutions in the market, but none of them do the full job. So the security is actually based on different solutions all patched together, one on top of the other. Any questions? That was fast. Thank you very much.
Yeah, thank you. Thank you.